Topics covered in some applications of trigonometry. Welcome, everyone. Today, we begin a new and exciting chapter, some applications of trigonometry. Up to this point in our studies, you have primarily focused on trigonometry as a set of theoretical identities and ratios. However, this chapter marks a significant transition from the abstract study of triangles to the concrete measurement of the physical world around us. Our primary learning objective is to master the practical implementation of trigonometric ratios, specifically sine, cosine, and tangent, to solve real-world problems involving unknown lengths and angles. We will focus our attention on the concept of heights and distances. To do this effectively, we must first become familiar with three fundamental terms. First, the line of sight, which is the imaginary line drawn from the observer's eye to the point being viewed. Second, the angle of elevation, which is the angle formed between that line of sight and the horizontal when you are looking up at an object. And third, the angle of depression, which is the angle formed with the horizontal when you are looking down at an object. As we move forward, we will see how these very concepts serve as indispensable tools in professional fields, such as astronomy, navigation, and engineering. Real-world applications of trigonometry. Now that we have established the fundamental concepts, such as the angle of elevation and the line of sight, let us explore why these tools are so vital. The true strength of trigonometry lies in its ability to calculate distances and heights that are impossible to measure with a physical tool. This utility is evident across many professional fields. In astronomy, for example, we use these principles to determine the immense distances between Earth and celestial bodies, such as stars and planets. In the field of navigation, pilots and ship captains utilize trigonometry to determine their exact position and their distance from a specific landmark. Furthermore, for those in civil engineering and architecture, these calculations are essential for determining the slope of a roof, the height of a skyscraper, or even the structural integrity of a bridge. Similarly, in geography and surveying, trigonometry allows us to map terrains and measure the height of mountains or the depth of valleys where direct measurement is physically impossible. Ultimately, by mastering these applications, you will develop the analytical skills necessary to translate a real-world physical scenario into a mathematical model. This process serves as the essential bridge between the geometry we learn in the classroom and professional scientific practice.